Good afternoon. I'm Dennis Galucki, and welcome to the 523rd Imagine Buffalo program and our 145th virtual Imagine Greater Buffalo program, hosted by our wonderful Buffalo and Erie County Public Library. Now, we thank you for joining us today and remind you that this program is created by the Center for the Study of Art, Architecture, History, and Nature, or C-SAAHN, as I pronounce the acronym, and ImagineLifelongLearning.com. Before we get started, just a little housekeeping. Everyone watching will be muted and your video turned off. If you have a question or comment, please type it into the chat box and we'll go through as many as possible at the end of the presentation. We are recording this program so you can watch it again later on the Downtown Central Library's Facebook page and YouTube channels. And please, we hope you share the link with others. Now, on to our featured speaker. Mark Percy has been the director of the Williamsville Central School District Space Lab Planetarium for over 20 years. Built in the 1960s, the planetarium is located in Williamsville North High School and offers programming that brings the cosmos to both students and adults from across Western New York. Mark is also the founder of the Buffalo Eclipse Consortium. Leading up to the 2024 Total Solar Eclipse on Monday, April 8th. The consortium is working with local organizations like the library and the Buffalo Museum of Science to provide tips on how to safely view the once-in-a-lifetime event. Today's program is titled Eclipse 101, the whats, whys, hows, and wows of solar eclipses. Mark, been looking forward to this. Take it away.
All right, thank you very much, Dennis. And added to my credentials, I would put in there a two-time totality survivor. 2017, under the urging of my colleagues in the planetarium world, I did not stay in Western New York because they said you need to experience totality, and they were absolutely right. My family and I went down to Kentucky to experience that total eclipse. And then a couple years later, I actually went to South America, to the nation of Chile, to experience a second total eclipse and learned a whole lot more about the phenomena that occur, how to engage with it, as well as what can go right and what can go wrong during an eclipse event for a region. So I'm going to try to touch on what to expect and how to keep yourself safe. And then we as a community here in Western New York have to think about how do we make the best of this and make sure that we have as little of the unpleasantness as possible that sometimes experienced. Okay, so starting my slideshow here. All right, so this slide here shows us the very basic occurrence or the basic situation for a solar eclipse. The bodies are definitely not to scale. They're millions and millions of miles apart, would seem very tiny if we were looking at them at scale. So we always have to mess around with that. But basically what's happening is that the moon is getting in between us and the sun. But the sun has a width. And that means that we can cover part of it or cover all of it, as compared to like a star. Since a star is a pinpoint of light, it's either blocked or not. It's a binary question. But with the sun, we can block part of its bright area or all of it. And then inner part of the shadow, where all of the bright part of the sun is blocked, is known as the umbra. You may recognize that word from umbrella. Those were invented initially as a way to shade yourself from the sun when we didn't have sunscreen. And then the area around that where there's partial blockage of the sun is known as the penumbra. And that may come into your vocabulary talking about a penumbral or penultimate kind of event. Now, this diagram here from Rice University, I like a little bit better because it's still not to scale, but it does help you understand that that umbra, that inner area of the shadow, is narrower and narrower as we get closer to the Earth. And by the time it reaches the Earth, it's no more than about 100 miles wide. So considering the size of the planet, the chance of you being in that umbra is very slim, about a 1 in 10,000 shot for any given solar eclipse. The penumbra around it is much larger, and you have a much better chance of being in there. And we were recently, not just in 2017, but we had another partial eclipse a couple years ago, right at sunrise. And many folks who are astronomy enthusiasts have experienced a partial eclipse without trying too hard. But getting yourself in that umbra is the hard part. So, yeah, I had to travel to Kentucky, then to South America, but we are incredibly lucky here in Western New York that umbra is coming right to our doorstep. Now eclipses actually do occur every 6 months, but the chance of you being in that umbra again is very slim. But I do want to briefly explain what we call an eclipse season. So every month as the moon orbits around the Earth, it gets in between us and the sun at the phase called new moon. But we can't see a new moon because it's all dark. And if it's not going right in front of the sun, you're not going to see anything. That's caused by the fact that the moon's orbit is tilted with respect to the rest of the solar system. It's not much. It's only about 5 degrees. So this diagram too is exaggerated. But that tilt does not change with the Earth's orbiting around the sun. So what happens is that every 6 months, there's an alignment of the crossing of that tilt with our solar system plane, which allows a possibility for an eclipse. So we actually had a solar eclipse 6 months ago. It was visible in Australia, and there'll be another eclipse 6 months after this. But that one, I believe, is only visible over in the very southern tip of Africa, or it might be South America. I don't know. But it's not coming to us. Now, Rice University has actually been a great source of this graphic material. And if you're looking for stuff, you may want to seek them out on the web. But this video here that we're looking at shows what happens during the course of an eclipse. The moon is always in motion as it orbits around us. So what we can see here is at an eclipse season, when that alignment is right, the moon shadow can sweep across the Earth, forming what's known as a path of totality. So there's a line across the globe where people get to see the total eclipse. But these events always come in a pair with a lunar eclipse, because the other crossing point of the moon's orbit is on the other side, and at full moon, either just before a solar eclipse or just after a solar eclipse, we can get the opposite type where the moon passes through the Earth's shadow. Now those are a lot easier to witness because they're happening up in the sky. The only particular place you need to be is on the nighttime side of the Earth so that you can see the moon. But anybody with clear weather on the nighttime side of the Earth can observe a lunar eclipse. But that total eclipse, that's the real rare thing. All right, now let's go to the next slide here. In a space-based view, this is gives you a picture of what's happening to form that path of totality. So you can see that dark spot. That's not a black hole or something. That is actually the inner umbra sweeping over the Earth. And it's going pretty fast. One question that comes up a lot is, could you keep up with it in an airplane? And the answer is no. Not even with a high-speed research jet could you actually keep up with it the entire time, because it's going at least about 1,700 miles an hour. But that's only at the middle of the path where it's slowest. So there have been projects that tried to keep up with the shadow that gave people a longer duration of totality, but definitely not for the entire duration. And then this image here is actually so far the best picture of a total eclipse taken from space. And what I like about this is a few different things. Number one, you can really see that inner umbra where people are getting to witness the total eclipse. And then around that, you can see the penumbra fading off. The further away you are from that umbra, the less of the sun is covered and less of a partial eclipse. So on the far reaches of this picture, the upper right corner, those people aren't in even the penumbra, so they're not getting any particular event. Not really eclipse related, but another thing I like to point out in this image is the Earth's atmosphere that you can see along the upper edge. And remember that Earth's atmosphere is very special. It's only about 60 miles thick, and beyond that is the deadly environment of space. So we should always take time to appreciate what a great environment the Earth is, and hopefully everybody does their part to keep the Earth and its atmosphere in good shape for many years to come. All right, now our folks at greatamericaneclipse.com came up with this really cool video that shows a lot of detail about our path of totality in 2024. The very first people to witness this eclipse could be out in a boat in the Pacific Ocean. And this one then comes ashore on the west coast of Mexico through the state of Durango. And if you're looking for clear sky chances, actually the mountains of Durango have about a 90% chance of clear skies on eclipse day. And then as the shadow proceeds northward, the chances of clear skies go down a little bit. But yeah, there's a lot of folks in Mexico that are going to get to witness this. And then here we see the border with the United States. And now we see some of the major communities that are going to be able to enjoy this. San Antonio, the downtown, is just to the outside of the path of totality, but Austin is within it. But neither of those communities are right in the middle. Being right in the middle is where you get the longest duration of totality. So here we see Waco's a little bit better situated, as is Dallas. But if you think about the number of people, we're talking about millions and millions of people. Estimates by the National Science Teaching Association have come up with a number of about 500 million people. 500 million people will be able to witness this eclipse either as a partial or a total eclipse in this 2024 event. All right, coming up through the Midwestern states, we can see here that St. Louis is just outside the path. So with a short drive, you could witness the total eclipse. And, you know, another message to get through to people is being outside of totality is like almost winning the lottery. You know, getting 5 out of the 6 numbers for the big jackpot is not the same as hitting all 6. Okay, here we're getting closer to Western New York. We see Indianapolis is almost in the middle. Cleveland is actually very well situated. And then look at this. Buffalo is smack dab in the center of that shadow. So the shadow's moving a little bit faster here than it is in the middle of the paths, which cuts down our duration of totality a little bit. But we'll end up with almost 4 minutes of totality, which is very exciting. That's actually about 1.5 minutes longer than the 2017 eclipse at maximum. All right, so here's a map that shows the outer limits of the eclipse. So you can see there's communities in central New York that'll be very close, but not within the path. If you look to the north, the city of Toronto, home to 6 million people, is just outside the path of totality. And this is why we need to think about what's going to happen here in Western New York. Yes, it's a weather dependent event. If it's a lousy day and, a week when you don't even know the sun exists, we won't get the droves of visitors. But if it's even a partly cloudy day, and people in these communities think, well, I'm going to take my chances and take a short drive to Western New York, we could wind up with more visitors than have ever come into this region for an event before. And really the hot spot, the place where you really want to be, is that center line. So you can see on this map that it goes right south of downtown and then up through Cheektowaga. My planetarium here is only 7 miles from it. So that's the real hot spot. All right, so let's take a look at what happens during the total eclipse. First of all, notice this perfectly blue sky. That's what's going to happen on eclipse day, right, everybody? We're all going to keep our fingers and toes crossed that it's a nice cloudless sky. But during the morning, nothing will be different. And even in the very beginning of the eclipse, unless you're using a solar eclipse glasses or another viewing method, you won't really detect the dimming when the bite out of the sun is small. But over about an hour and a quarter, that bite will get deeper and deeper and deeper. And I'm going to pause right about here. So in 2017, many of you may remember that partial eclipse here, noticing like a reddening around us. Well, it turns out that the edge of the sun is actually redder, so that might be one of the first phenomena that you notice. Another thing is that the shadows on the ground will become sharper because the sun is actually a smaller object and there'll be less shadow blurring. So that's something you might notice. This is when it gets really fun to make projections of the sun with anything with a hole in it. It could be as simple as a piece of paper with a hole, or it could be a calendar. Lots of cool ideas to make projections of a crescent sun. And then in the last few minutes, things get really weird really fast. Oops, I went ahead. So just before totality, when the last bright part of the sun is blocked, what will happen is that the crescent sun will begin to break up into little beads of light, which are actually shining through valleys on the rough edge of the moon. That phenomena is known as Bailey's beads. And then when those disappear one by one and we're left with the very last bright spot is when it's dark enough for the corona to come into view. Hold on, let's see if I can get this video to be paused right where I want it to be. Right there. Oh, it's advanced. This is not cooperating. I apologize, folks. You'd think after that quarantine teaching, I'd be quicker at this. Okay. When the last bright part of the sun's bright area is exposed, it becomes dark enough to see the corona of the sun's outer atmosphere. And that phenomena is known as the diamond ring effect, because you can see a ring of corona with the last bright spot. And only when that last spot of the bright part of the sun is blocked and we're in totality can you take your eclipse glasses off. And then you got to watch for that bright part to come back out again so that you know when to get your glasses back on your face. And, how do I know how to time this? I'll talk about some other tools in a little bit, but real simple rule is if you can see anything of the sun through the glasses, you should be wearing them. But during totality, you're actually going to want to take those glasses off or you'll miss the view of the beautiful corona. Now, why are we so worried about danger? Well, we all live on Earth. We've all accidentally glanced at the sun and lived to tell the tale. But that's because you have a natural reflex to look away, because your iris that closes down your eye is a muscle. But that reflex is diminished as the partial eclipse gets deeper and deeper. So it becomes easier to stare at the sun. So this is why we need to get this messaging out about until absolutely every last bit of that bright part is blocked, you've got to use the eye protection. So be on the lookout for that. And here's a diagram that really kind of sums it up. Is all stages of the partial eclipse solar filters are necessary, but boy, do you want to use look with the naked eye during totality, because no camera, I know that picture in the middle looks pretty interesting, but no camera can really do justice to how beautiful the corona is. Now, you might be wondering what these little C's are. Those are what are known as the contact times, and I'll explain those in just a moment. But C1 is the very beginning of the partial eclipse. C2 is the beginning of totality. C3 is the end of totality, and C4 is the end of the partial eclipse. So just overall time frame, we've got about an hour and a quarter of partial eclipse before, another hour and a quarter of partial eclipse afterwards, and for us about 3 minutes and 45 seconds of totality here in the Buffalo area. Now, those times you saw the shadow sweeping across the country in the animations, those times depend on where you are. So here at Williamsville North High School are the contact times down to the second. And I got to say, that is one thing that's pretty amazing. As much as I know we know this, it is right down to the second that you will see that first little bite taken out. So it's kind of, I don't know, it just amazes me anyways. So what do we do? Where do we get this data? Lots of interactive maps are now available. We're very lucky to have these tools that we didn't have for previous eclipses. And you don't need to try to copy down all these websites, because if you just try searching Interactive Eclipse Map 2024, you'll find several different versions. And if you want to be extra safe, check a few of them and cross-check the data to make sure that you're getting consistent answers. Another thing that's a wonderful tool is the Talking Eclipse Timer app. This is an app put together by an astrophotographer with lots of experience in eclipse photography, and this one will actually count down to the beginning and end of totality for you audibly, so you don't have to worry about trying to look at your phone. It'll give you instructions about when to take the solar filters off and when to look for different phenomena. So yeah, it does cost a few bucks, but it's really super helpful. All right, this animation shows us a phenomena that I mentioned earlier, Bailey's beads. So you see it breaking up. Oh man, you see it breaking up into those spots there. So, you know, the moon actually has mountains and valleys on it. So what happens is the mountains begin to dissect that crescent. And then as those little points of light, bright light, are pinched off, that's when the chromospheres, like the lower atmosphere of the sun, and the corona come into view. All right, so here's a list of some different phenomena that you could read up about and know a little bit more what to expect. It won't get to be a nighttime dark. It will be like a deep twilight, but it should be dark enough to see bright planets and stars. And it is different from regular twilight because it's all around you. Normally, twilight is just in the direction of the sunset, but it's a very different feeling to it. And one thing that really struck me was the rapid temperature drop. It dropped over 20 degrees in just a few minutes during each eclipse that I experienced. So how do we protect ourselves from eye damage? Eclipse glasses are the easiest, safest way to enjoy it, but just remember, these are only for use over your eyes. They're not meant to be used in conjunction with telescopes, cameras, or binoculars. The only exception to that would be a cell phone, because a cell phone isn't passing any actual light directly through it. It's just like a TV screen. So you could hold the eclipse glasses over a cell phone camera, but don't try to use those paper glasses with a regular lens camera or binoculars or a telescope. And do make sure that they have the ISO standard on them. Unfortunately, we had some issues with counterfeits during 2017. So that ISO standard lets you know that they're safe and meet the safe criteria. Projections. This is why we got to be careful here. So, you know, we can actually start a fire with magnified light. And this is where our danger level is increased. But magnification does provide some details that are really pretty cool. So here's a real simple setup for magnification. You can see on the right an image of the sun, and those spots are sunspots. We're going to actually probably have a lot of sunspots this time around. So those are pretty cool, but you've got to be very careful because there is a focal point in between the telescope and the paper. And if somebody were to put their eye at that focal point, then we're talking about instantaneous severe damage to the eye. So what do? I'm not calling anybody any names, but we can foolproof this with a device called the sun funnel. It's just an automotive long neck funnel put over the telescope eyepiece, and then a piece of rear projection screen from the theater world so that you make a projected image. And now the focal point is inside the funnel and there's no way to have an accident. This particular telescope it's on is a rather large one, so I've also added in an aperture reducer because I don't want to overheat the optics of the scope. But these are something you can make. The only tricky part is that rear projection screen is usually sold by the yard, not in little pieces. So this would be a good thing to team up with other enthusiasts and buy a yard or two so that you can all make sun funnels. There are special filters meant for cameras and binoculars, but they always have to go in the front end. Never, ever, ever use one that goes in the back end because you've already concentrated the light at that point. We want to stop that light from getting in to the device. So on the right are some homemade filters. The filter material for scopes and binoculars is also sold. But this is something not to wait until eclipse day to mess around with. You would want to get your supplies, get your stuff tested out early so that you're nice and familiar with it before eclipse day. And then there's other projection methods that I mentioned. On the left is a colander giving us numerous projections of a crescent sun. The device on the right is a little pricey, but makes a nice big projected image of the sun. And I just want to finish up with this beautiful picture taken by one of the people on our trip to Chile. I can't wait for you all to get to experience this. This is just the most magical thing you'll ever see in the sky. So with that, are there any questions?
Well, there should be a bunch. Mark, well done. Thank you for that wonderful summary. From the collaboration standpoint, the consortium that you put together, this is a private experience for some and a communal experience for many. What are we suggesting as gathering spots where lights won't just pour on as soon as it gets dark? Or what are you hearing are likely spots for the community to gather and see this together?
That's one of the reasons that I'm running around like a crazy person these days. Is through the holidays, people were focused on other things, but viewing opportunities are popping up left and right around the area. And the Eclipse Consortium website does list those that we're aware of, but I expect to see a lot more. What are you looking for in a viewing site? You really just need a clear sky to the southwest because you don't want to have a tree or a building in the way. So any open field would do. And it is a little different than normally when we think about astronomy events, we think about going to a certain venue, but you may want to just consider staying locally, especially if it's a really nice day, because it could get pretty hard to travel around the region if we do get the clear weather and the big crowding that tends to happen. So rather than traveling somewhere away and taking a long time to get home, maybe just find a park nearby or at least an event that's in your local community.
Okay, and the other point, let's say it's a cloudy day, sadly, and we don't have that effect. But you mentioned the drop of 20 degrees in temperature. Are there other things that we'll experience nature-wise if, in fact, we can't see the actual eclipse, but experience the results of it?
Yes, and that's one thing that's real important is that the eclipse will happen no matter what.
Mhm.
It will get nighttime dark no matter what in the middle of the afternoon. If it's completely clouded over, the temperature drop will still happen, but it may not be as dramatic. But one thing you could look for is changes in wind direction, changes in animal behavior will probably still happen too, because animals will, not knowing what's going on, think that it's nighttime all of a sudden. Another thing to keep in mind too is that what's most likely here in Western New York for that time of year is a partly cloudy day, where some people are going to hit the jackpot, some hearts will be broken, but hold out, because when the upper atmosphere cools as we approach totality, a lot of times the cloud cover will dissipate just before the eclipse. So yeah, don't give up hope and stay out there, keep observing, because you never know
Okay,
what's going to happen.
good advice, good advice. Ann, how are we doing for questions?
Well, one of the questions we did get in was about what he was just talking about what happens if it's cloudy, what the effects will still be. One of the questions is, will there be any chance of seeing a partial eclipse from the southern South Carolina coastline on April 8th?
Yes, I would take me a moment to find one of those maps and click on it. But that's the nice thing is those maps, those interactive maps, will tell you what'll happen in any location, even if it's not in the path of totality. And some of them even open up a little simulation, will show you like how deep the partial eclipse will get. But yeah, I mean, I'm not telling you what to do, but I would try to be somewhere along that path of totality instead of outside of it on the day.
And also, we want to point out that the Downtown Central Library will be open that day. And as we did in 2017, we're anticipating that out in the Reading Park, we will have a viewing experience for anyone that wants to be downtown that day.
Good. Do you think
But
the
that's
lights go off in the city? Would the lights reappear? Street lights, I'm thinking.
Oh, I meant to address that before. Yes, we've actually discussed the technology with transportation planners, and we just don't have the technology in place to prevent automatic lights from coming on. So I would say either go someplace where they have control of the lights and can disable them, or go someplace where there aren't automatic lights around, because just like the animals are going to think it's nighttime, so will the street lights.
Mhm.
So if you set yourself up right under a bank of street lights, you're going to regret it.
Yeah.
also, someone is asking, will there be eclipse parties? Is there somewhere, Mark, where all of the eclipse activities that the consortium is aware of are posted or will be posted for people to look up and see where they could go to celebrate this or be involved in it?
Yep, we established the website buffaloeclipse.org many, many years ago, and it's paid off, because if you just Google search or whatever your favorite search engine is, Buffalo and Eclipse, it'll take you right there. And there is a locations page where we're listing everything that we're aware of.
Great. That's everything that's on here, Dennis.
All right. Well, we'll give folks just another minute. I don't mind going over a little bit here. This is most informative, Mark. You don't have to go to South America. You don't have to go very far to enjoy it. As you said, it comes to us in this case, and your advice is going to go a long way to help us appreciate it.
Yeah, let me throw this in.
Please.
As soon as the eclipse is over, everybody's going to be asking, when's the next one? In the year 2045 is the next eclipse in the United States. And that path of totality actually goes right through Disney World. So imagine that scene. And the next one that passes through Buffalo is in the year 2144. So even if you eat your vegetables and do your exercise, I don't think anybody alive today is going to see that next total eclipse here in Buffalo.
That's You're absolutely right. That'll be the next question. So, so we handled it today. Wonderful presentation, in effect, Mark, and good work anticipating where the world was going. The old Wayne Gretzky, go where the puck's going, not where it's been. And you've been leading that charge for this total solar eclipse for several years, and finally it's payday coming up, and the world is recognizing your good efforts, and we express our appreciation here.
Well,
So-
thank you. And I just want Western New York to have the best experience possible.
And perfect. And so does the library. And again, we thank you. And folks, thank you for joining us today. We hope you'll join us next week here on Zoom, as we're joined by two team members from the Buffalo Niagara Medical Campus, Mark McGovern, who's the Director of Construction and Infrastructure, and Jamie Heyman Burney, who's the Director of Planning and Implementation. JD Hartman will be our co-host for that event. So I look forward to seeing you next week. I'm Dennis Galucki. Be well and good day.